Good morning to all. My name is Ajit Gopi. I am a research scholar in renewable energy and environmental engineering under the University of Malaysia, Pahang. I am thankful to the organizers for giving me an opportunity to present my paper. The title of my paper is Design and Simulation of Solar Rooftop Projects for an Energy Self-Reliant University Campus. Solar PV power plants are being installed worldwide, mainly in two forms: solar rooftops for residential purposes, industrial purposes, and for commercial purposes. All belongs to all solar rooftops. The second category is megawatt scale solar farms, mainly feeding bulk power to the utility, to the grid. Among many categories, solar rooftop are more decentralized in nature, which can be installed with a very short time and with easiness. Academic institutions are very good institutions for installing solar PV power plants because they will have sufficient rooftops available for installing solar power plants. In academic side, the buildings are conventionally utilizing the conventional electricity power for their needs. This research paper discusses an integrated and comprehensive approach for installing solar rooftop power plants in a university campus at Thiruvananthapuram in the state of Kerala in India, and to offset the university's electricity needs and to make the campus self-reliant in terms of electricity generation and consumption. This solar project under this research paper is intended to reduce the carbon footprint of the university and aiming for a carbon neutral and self-reliant campus. Objectives. The objectives for this research work are to conduct the feasibility study of a university campus by assessing shade-free rooftop buildings inside the campus and to make the campus a carbon-free and self-reliant one. Second, design and simulation of the PV projects utilizing industry standard softwares like PVsyst and optimizing the design to offset the power needs of the campus. Third objective is economic and environmental analysis of the project to find economical feasibility and environmental benefits of the project for energy self-reliant university, for a energy self-reliant university campus. And coming to the site details, the site is at actually south of India in the state of Kerala. It's called the Karivattam campus of the University of Kerala. It has got a lot of rooftop with various department buildings. And the site has an area of more than 10,000 square meters. The methodology includes site visit and doing the feasibility study, including the primary and secondary data collection, design and simulation of the project utilizing PVsyst software, the famous software developed by the University of Kerala, and to find out the optimum solar generation needed to offset the campus power needs. Third is the third methodology, like will be finding the economic and environmental analysis of the project utilizing RETscreen software to find the economic feasibility of the project and to find the economical benefits of the project. So two softwares are used for doing this kind of analysis in this project as part of the methodology, along with the site visits and for conducting the data analysis. The primary data collection involves the campus visit. It involved the campus visit, actually. Visited the campus, the university campuses, houses, teaching and research departments, administrative office, staff quarters, as well as student hostels, libraries, etc. And the connected load, the peak power demand of the project is 450 kVA and off-peak demand is 150 kVA, and the university campus requires an average daily electricity need of 6 megawatt-hour. At present, the power is taken from a substation nearby through 11 kV feeders. And currently, a 100 kilowatt solar power plant is installed, which you can see in the picture here. So that is the actual inspiration for going further forward to go for a higher thinking of getting this complete campus electrified or solarized to make the energy self-reliant campus or carbon neutral campus. The methodology, as part of the methodology, the study at the university is conducted on different buildings, rooftops. The area has been measured. It includes different departments of the university, like biochemistry, chemistry, computer science, etc., etc. The methodology includes, as told, the design of the solar rooftop projects utilizing PVsyst software and economic analysis, environment analysis using RETscreen software. Coming to the results, the data analysis gives some very good insights to define the project, to define how much capacity solar power has to be installed in the campus to offset the energy needs of the campus. The public utility here, called KCB Limited, has conducted an energy audit at the site in July 2017 to June 2018. That data has been collected, and it was seen that 1941 megawatt hour of energy has consumed in a year, in the year 2007 to 2018. The data of the previous year, July 2019 to June 2020, has also collected. It is above 2200 megawatt hour and expected again an increase of 10%. So based on this data, a solar power plant has to be designed with 10% of above of the previous year. It will be 2420 megawatt hour it should produce. So utilizing PVsyst software, it is found that a capacity of 1.6 megawatt capacity solar power plant rooftop projects in different buildings can offset the university campus in a futuristic perspective. Accordingly, a total 1.6 megawatt peak capacity solar rooftop project can generate, has been simulated, and it is found that it can generate 2553 megawatt hours, or 2553 megawatt hours of energy, which is just above the requirement of 2420 megawatt hour. But in a futuristic concept, this can completely offset the campus electrical needs in a futuristic way and thus offset the energy needs. The design of the project utilizing PVsyst software gives these results. You can see that the total generation is per annum is 2,553 megawatt hours and a specific production of 1,596 kilowatt hour per kilowatt peak per year with a performance ratio of 76.7 and with a solar resource of 2039.6 watt hour per meter square. This is the result of the PVsyst simulation, and the results has been graphically represented here. It gives the total produced energy, specific production, and performance ratio of 76.7% as described earlier. And coming to the environmental and economic analysis. The environmental and economic analysis is conducted utilizing RETscreen software. It is found that 2,293.6 tons of carbon dioxide is replaced if this project is implemented per annum. This environmental GHG reduction of 2,293.6 tons, according to the RETscreen, is equivalent to 420 cars and light trucks not used, about 9,85,406 liters of gasoline not consumed, 5,334 barrels of crude oil not consumed, 2,293 people reducing energy by 20%, 521.2 acres of forest absorbing carbon, 211 hectares of forest absorbing carbon, 790.8 tons of waste recycled. So this much of benefits are produced by offsetting the campus with the solar energy by installing a 1.6 megawatt peak solar power plant. Coming to the environment economic analysis, it is also conducted utilizing RETscreen software. RETscreen software is a Canadian software developed with the government of Canada. The RETscreen results gives that the project has a simple payback period of about 3 years and with a electricity export rate of 8 rupees, because that is the current export rate of electricity there in the campus. The project has an internal rate of return of 33.9 pre-tax IRR equity, which is a very good number, positive number, and the project has an NPV, net present value, of 43,000. It is like it is more than that. The project has an energy production cost of 1.57 Indian rupees per kilowatt hour. So the main figures are the simple payback of about 3 years and the NPV, a very high value, and very high positive value. That is very important. And the IRR above 12 or above 15, that makes a sound significance of the project. And coming to the conclusions, the design and simulation of the project of solar rooftop projects for a energy self-reliant campus is made, and the project will have a capacity of 1.6 megawatt peak. The design is carried out with the PVsyst software and economic and environmental analysis done with the RETscreen software. The project has got simple payback of 2.9 years, pre-tax IRR equity of 33.9%. This project can bring GHG emissions reduction of 2,293.6 tons of carbon dioxide. Thus, the proposed solar rooftop project is both environment friendly and economic feasible. A university becomes carbon free in terms of electricity generation when it generates all electricity requirements from renewable energy sources. That is the outcome proposed by this research project of installing an 1.6 megawatt project. This project will offset the electricity needs of the Kerala University campus and thus helps the campus to become a self-reliant university in terms of electricity generation for meeting all its power needs. And authors acknowledge the university for permitting to conduct the feasibility studies for the project. Also, authors acknowledge the Agency for New and Renewable Energy Research and Technology, ANERT, Kerala State Renewable Energy Nodal Agency in India, for the technical help for collecting the data. The others are grateful for the financial support provided by the university. Malaysia Pahang, through the Postgraduate Research Grant Scheme PGRS 1903172. And the references. And with that, thank you all for attending my humble presentation. Thank you again for giving this opportunity. Thank you.